See the next problem. Using the Cauchy integral theorem, and its extension, evaluate integral over C dz by z into z plus 2, where C is any rectangle containing the points z equal to 0 and z equal to minus 2 inside it. This is the problem. Solution. Solution. See, to solve this problem, actually, what for the function, if the integrand, what is that? Let f of z equal to, if I consider z into z plus 2, then f of z is not analytic. At what points? At z equal to 0 and z equal to minus 2. Z equal to 0 and z equal to minus 2. And these singularities, these singular points, what are those? Z equal to 0, z equal to minus 2 lies inside the given rectangle. Rectangle is not given. Okay, the equation of the rectangle is not given, but the points lies inside. You can take any rectangle. If I consider this one rectangle, okay, this is x-axis and this is y-axis. This is z equal to 0. And where is z equal to minus 2? Here, z equal to minus 2. Okay, these 2 points lies inside. Therefore, f of z is not analytic here. F of z is not analytic at z equal 0, z equal to minus 2. Therefore, what is integral over C, f of z is at Cauchy's theorem cannot be applicable. Cauchy's theorem, what it states, if the function is analytic inside C, what is this one? This is the curve C, boundary of the rectangle. And these 2 points lies inside, therefore f of z is not analytic inside the rectangle. Okay, clearly. Therefore, f of z is not analytic in the rectangle. So Cauchy's theorem not applicable. So we have to go for Cauchy's integral formula. Or Cauchy's extension theorem. See, here the question is clearly mentioned. Remember, using Cauchy integral theorem and its extension evaluate. So when the problem is given like this, we cannot apply Cauchy integral formula. Okay, I have to apply its extension. What is its extension? Let us see now. See, construct the circles. Construct the circles C1 and C2. 2 circles. I'm taking C1 and C2. Enclosing the points z equal to 0 and z equal to minus 2 respectively. respectively z equal to 0 and z equal to -2 respectively of radii r1 and r2 of radii r1 and r2. So what is the picture of this one? See, this is the rectangle. All of you understand this problem. Cauchy extension theorem. Cauchy's extension theorem problem. This is z equal to 0. I'm taking z equal to -2 here. What is this? How to apply Cauchy extension theorem, and what is the curve C? This is the boundary of the curve C, rectangle. Okay. Now, with z equal to 0 as center, construct one circle, that is C1. Same logic. Z equal to -2 as center, construct another circle, C2. These two are the circles. And remember, these two circles cannot intersect each other. Okay. Such that, I will write here, such that, how these two circles will be? Such that both these circles lie inside the curve C and lie inside curve C and do not intersect each other, and do not intersect each other. Do not intersect each other. Okay. Now this is the domain D, entire domain. This is the rectangle. Now, what this becomes? Now, domain D bounded by what? See, when I consider these two circles, now the domain D bounded by what? Domain D bounded by what? One curve C, next one circle C1 and another circle C2 is a multiply connected region. Because there are holes now. I have taken holes, circles, multiply connected region or domain. Hence, now I can apply Cauchy's extension theorem. Hence, by using Cauchy's extension theorem, we have what is this? Cauchy's extension theorem. We have integral circulation over C f of z dz is equal to what? Since there are two holes, summation C1 plus integral over C1 plus integral over C2. Integral over C1 plus integral over C2. That implies what this becomes? This is circulation over C, f of z dz equal to circulation. What is C1? Mod z equal to some radius. What is that radius? R1. Okay. And what is the function? 1 by z into z plus 2 dz. Plus, what is C2? Mod z plus 2. Center is -2. Mod z plus 2 equal to R 1 by z into z plus 2 dz. Any doubts? Okay, once again, I'm taking, see, f of z is this one. Clearly, it is not analytic at z equal to 0, z equal to -2. And in the problem, it is given these 2 points lies inside. These 2 points lies inside the rectangle, that is inside the domain D. This is the domain D. And I have to apply Cauchy's extension theorem, not Cauchy's integral formula. We can solve this problem by using Cauchy integral formula also. I will tell that also. Okay. Now, f of z is not analytic inside the rectangle. Hence, what we have to do to apply extension theorem, at these singularities z equal to 0 and z equal to -2, construct two circles. One is C1 and another one C2 with the center 0 and -2 of some arbitrary radius, such that these two circles lies inside the circle, inside the rectangle, and they do not intersect each other. Okay. Then what is this domain now becomes? It is a multiply connected region, that is triply connected region. So what is Cauchy's extension theorem for triply connected region? Exactly this. I'm substituting this. Now see, all of you, this is one problem. This is one problem and this is another problem. Got it? In the over C1, this is C1. you can write like this also, doesn't matter. C1 and C2. And over C1, what is the singularity? And I have to apply again Cauchy's extension theorem only, not apply Cauchy's integral formula. So what I have to do, this one, partial fractions. Let us take partial fractions. What are the partial fractions for this? If I take 1 by z here and 1 by z plus 2 here, z plus 2 minus z gets cancelled, 2 will be there, so 1 by 2 outside. This is first one. Plus same logic the second one, integral over C2, 1 by z minus 1 by z plus 2 dz, 1 by z plus 2 dz. Now listen, here integral over C1, 1 by z plus 2 dz equal to 0. Is it correct? What is C1? I will write here clearly. This is C1. What is C1? Mod z equal to 1 equal to 0. Since 1 by z plus 2 is analytic everywhere of mod z equal to 1. Because what? Mod z equal to 1 means this is the circle. This is 1. Where is the negative point? Minus 2 is there. Z equal to minus 2. This is minus 2 outside. So within this circle, the function is analytic everywhere. Within this circle, function is analytic everywhere. 1 plus 2 z is analytic everywhere. You write using, now this is Cauchy's theorem. This is Cauchy's theorem. It's a value 0. Same logic, similar. And integral over C2. What is C2? Mod z plus 2 equal to, this is R1. Some radius R2. 1 by z if I take, that means this integral, and I am taking this integral. These two integrals. Okay. The value of these two integrals, and this is also 0. Since 1 by z is analytic everywhere. Analytic everywhere of, what is the circle? Mod z plus 2 equal to R2. Mod z plus 2 equal to R2. What is mod z plus 2? So where is the circle? This is minus 2. Okay, this is the circle, for example. And where is z? 1 by z, z equal to 0 is outside. So the function 1 by z is analytic everywhere. This is also using Cauchy's theorem. Okay, therefore, what we have now, after reducing these two integrals to 0, integral over C f of z dz is equal to what? The remaining parts over C1 mod z equal to R1. What is this case? 1 by z will be there on the first integral. 1 by 2 integral over C2 mod z plus 2 equal to R2. And what is the left one here? Z by 2 dz. I think minus will be there. Is it correct? This 2 integral 0. Next one. Now, what is this answer now? This is equal to. What is this answer now? Yes, anyone? Yes.
0, sir.
Right? No? How it is 0? How it will be 0? We have to not apply. What is this? We are not applying what? Cauchy integral formula. If you apply formula, problem will be completed. I already told you now one problem. What is that?
1 by 4.
See, this one. Z minus A or Z power n, I think we solved that, right? Do you remember? Z power n dz value. This value is what? 0 if n not equal to 1, minus 1. If n equal to 1, this value is 2 pi I. Do you remember? N equal to minus 1. Okay, I'm taking this is 1. If it is not clear for you, now see. Over C1 first. Over C1. Mod z equal to R1. What is z equal to then? R1 into e power I theta. what is dz equal to r1 I e power I, our standard method, starting method. Don't forget this, right? Therefore, what is this is, and over c1, theta varies from where to where, since it is a full circle, 0 to 2 pi, 0 to 2 pi. Therefore, integral over c1 1 by z dz is nothing but this is theta equal to 0 to 2 pi. Okay, 1 by z means what? Now this is 1 by z is what? R1 into e power I theta. And what is dz? R1 into I into e power I theta d theta. So which terms are getting cancelled? This one. Only I will be there. So I integral of d theta 0 to 2 pi. That is nothing but what value? 2 pi I. Now over C2 now. Over C2. What is C2 equation? Mod z plus 2 equal to R2. So what is z plus 2 equal to R2 into e power I theta? So what is dz equal to R2 into I into e power I theta d theta. And over C2, theta varies from, it is also circle. Over C2, theta varies from 0 to 2 pi. Therefore, over C2, what is this value? 1 by z plus 2 dz is equal to theta 0 to 2 pi. 1 by, what is z plus 2? R2 into e power I theta. And z plus 2 is what? Dz is what? R2 into e power I theta into I d theta. I d theta. Done. This is also what? I think 2 pi, you will get same answer, because 0 to 2 pi, this is I outside d theta. This is also 2 pi I. 2 pi I. Therefore, 1 implies, substitute these two values. Integral over C 1 by z into z plus 2 dz is equal to, what is the first integral value? 2 pi I. And what is the equation 1? Minus is there. Yeah, here minus is there. I will include that minus here. This is minus. This is minus 2 pi I. So answer is 0. Answer is 0. Now, this is using Cauchy's extension theorem. Now see R. We can solve this problem. We can solve this problem using Cauchy integral formula. Using Cauchy integral formula. What is that formula? Cauchy integral formula. Integral f of z dz is equal to over c 1 by 2 pi I. Is it correct? No, 2 pi I. I will write like this. 2 pi I into f of a by z minus a will be there. By z minus a will be there. Now, what is this problem? If the question is evaluate, just evaluate. So I will write evaluate integral over c 1 by z into z plus 2 dz, where z equal to 0, z equal to minus 2 lie inside any rectangle. Any rectangle. So the problem solution using Cauchy integral formula. Now if we take, so how to solve? Again beginning. If we take f of z equal to 1 by z into z plus 2, then it is not analytic. It is not analytic at z equal to 0, z equal to minus 2, which lie inside the domain of rectangle. Therefore, Cauchy's theorem not applicable here. Cauchy's theorem not applicable. So what I have to do? So would say, remember Cauchy's theorem now, whenever Cauchy's theorem not applicable with f of z, what is this Cauchy integral formula structure? Remember all of you, structure is, this is a fraction. F of z is numerator function. Remember, and denominator must be z minus a. Denominator must be z minus a. Remember these 2 points. Okay. Now, so what is f of z here? First, I am taking 1 by z into z plus 2. Now, consider not f of z. This is not f of z here. Cauchy's theorem not applicable. Therefore, f of z is not 1 by z into z plus 2. This is for our idea. Just for this is for your idea. Cauchy's theorem fails means f of z is not the full function. If I take the partial fractions of this to apply Cauchy's integral formula, I have to take partial fractions of this, exactly this, right? Then integral over c 1 by z into z plus 2 dz is equal to 1 by 2 integral over c 1 by z dz minus 1 by z plus 2 dz. This is over c. Done, right? Take this as 1. All of you see. Now consider 1 by 1 I am taking. Now consider integral over c 1 by z dz. Here f of z is what? See, I have to apply what formula? Cauchy integral formula. What is the structure? F of z by z minus a dz is equal to 2 pi I into f of a. So compare this one with this. Compare 1 by z with this. So what is f of z is 1. And what is a value? 0. Z minus a. Z minus a value 0. Okay. Therefore, using a equal to 0, singularity, you write like this. A equal to 0, lie inside rectangle. Inside rectangle. Okay. Therefore, using Cauchy integral formula. Using Cauchy integral formula. Integral over c. Just wait. Integral over c 1 by z dz equal to 2 pi I into f of a. So this is 2 pi I into f of a means what? Just 1. So value is 2 pi I. First one is over. Now coming to second one. Now consider integral over c 1 by z plus 2 dz. Here, what is f of z? 1 and a value minus 2. A value minus 2. Again compare with this. What is that? Integral f of z by z minus a dz equal to 2 pi I into f of a. So what is this value? Then using Cauchy integral formula, I am using this. CIF means Cauchy integral formula. 1 by z plus 2 dz is nothing but 2 pi I into f of minus 2. That is 2 pi I into, since f of z is constant, this is 1. So this is 2 pi I. And here also I will write one more step. 2 pi I into f of 0. That is equal to this, right? Now, therefore one implies integral over c 1 by z into z plus 2 dz. What is this value? First integral value 2 pi I. Second integral value 2 pi I. That is 0. So this problem is simple. So I'm doing a little bit lengthy, but just after writing this, you have to assume, yes, this is the first integral. This is my f of z. This is z minus a. Then you can write directly. Okay. To understand the concept, I am splitting into two parts. One is 1 by z, another one is 1 by z plus 2. 1 by z plus 2. Now, next problem. Cauchy integral formula based on, and its derivatives also, right? That's simple. Yeah, take this. Evaluate integral over c 1 by z square plus 4 dz, where First one, C mod z minus 2i equal to 1. Second one, C is mod z plus 2i equal to 1. Third one, mod z equal to 4. Mod z equal to 4. Now, solution. See, all of you. If we take, see, always I'm writing, if we take, this is compulsory, 1 by z square plus 4. If I assume f of z as, because always first check the Cauchy's theorem, whether it is applicable or not. If not applicable, then go for Cauchy integral formula. Okay, Cauchy integral formula. So first I am taking f of z equal to 1 by z square plus 4. 1 by z square plus 4. Then what is the singularities? This function is not analytic at what z square plus 4 equal to 0. So what are the z values? Plus or minus 2i. What are the z values? Plus or minus 2i. Now, are the singular points. Now, first one. What is the first one? C is, what is this? Mod z minus 2i equal to 1. It is a circle. It is a circle with center at 2i. So what is the shape of this circle? Actually, no need to draw the figure also. I will tell shortcut. Where is 2i? 2i will be where? Here 2i. Okay. And construct one circle. Okay. And if I write in terms of x and y, what is this becomes? X square plus y minus 2 whole square equal to 1. Okay. Radius is 1 unit. So this is one circle. This is the circle. And what are the singular points? 2i and 2i. When z equal to, see, I'm telling the shortcut. You can implement this also. When z equal to 2i, substitute in this mod z minus 2i. This is 2i minus 2i. What is this value? 0. Is less than radius. Is less than this radius 1. Therefore, less than radius 1 means z equal to 2i lie inside C. Inside C. Okay. Now, when z equal to minus 2i, mod z minus 2i, what is this becomes? Minus 2i minus 2i minus 4i. Mod minus 4i means 4. It is greater than 1. It is greater than 1. Therefore, z equal to minus 2i lie outside C. Outside the circle C. So only one point is inside. Only one point is inside. Z equal to 2i lies inside the circle. Inside the circle. Therefore, now Cauchy's theorem anyway fails if a function is not analytic, which are z equal to plus or minus 2i. So Cauchy's theorem not applicable. Here I will write Cauchy's theorem not applicable. Next time onwards, just by watching that, you can write. Now, therefore, first one, what is the function? Function is what? 1 by z square plus 4. 1 by z square plus 4. How can I write? Since I know the roots, z minus 2i, z plus 2i. Done? Now, over here, since z equal to 2i lie inside the circle C, we can write the above function as, this is very important now, 1 by z square plus 4 is equal to, since only which one is singularity? 2i lies inside. I will keep z minus 2i in the denominator and I will take z plus 2i to the numerator. Okay. Then Integral over C 1 by z square plus 4 dz is nothing but what? Integral over C 1 by z plus 2i. This is by z minus 2i dz. Z minus 2i dz. Here, what is f of z? To apply Cauchy integral formula, this is the what is the structure? I'm giving again f of z by z minus a dz. What is this value? 2 pi I into f of a over c, right? Okay. And what is the a value? 2i. Okay. Therefore, using Cauchy integral formula, we have, what is the answer then? This is integral over c 1 by z square plus 4 dz is equal to 2 pi I into f of a. That is 2 pi I into f of how much? 2i. So 2 pi I into what is f of z? Now this is my f of z. So 1 by 2i plus 2i. 2 pi I into 1 by 4i. So I gets cancelled. Pi by 2 is the answer. Answer is what? Pi by 2. This is case 1. And the second one. What is the second one? C is the circle. What is that? Mod z plus 2i equal to 1. Then at z equal to 2i, z plus 2i is equal to 2i plus 2i. That is 4i equal to 4 greater than 1. 4 greater than 1. Therefore, z equal to 2i lie outside the circle. Outside the circle. Now, when z equal to minus 2i, at z equal to minus 2i, mod z plus 2i is equal to minus 2i plus 2i. That is 0 less than 1. Therefore, z equal to minus 2i. Now, this point lie inside the circle. Inside the circle. Now, this is the point. Therefore, rearrange 1 by z square plus 4 equal to 1 by z minus 2i into z plus 2i as z plus 2i as that is equal to what? How I can consider this is 1 by which one should be inside? Z plus 2i. This point is inside, so keep in denominator and z minus 2i in the numerator. Therefore, integral over c 1 by z square plus 4 dz is equal to integral over c. This is my f of z by z minus a dz. Here, what is f of z here? 1 by z minus 2i. And what is a value? Minus 2i. So, whenever if you have any doubt, immediately you write this formula. Dz equal to 2 pi I into f of a. So, this is my f of z and a value minus 2i. Okay. Using Cauchy integral formula, we have integral over c 1 by z square plus 4 dz is equal to 2 pi I into f of how much? A minus 2i. So 2 pi I into 1 by z value minus 2i minus 2i minus 2i minus 2i. So 2 pi I into 1 by minus 4i. So minus pi by 2 is the answer. Minus pi by 2 is the answer. Then, and third case. What is the third case? C is the circle mod z equal to 4. C is the circle mod z equal to 4. Now, see, at z equal to 2i, mod z equal to mod 2i, that is 2 less than 4. At z equal to minus 2i, what is mod z equal to? Mod minus 2i. This is also 2 less than 4, radius 4. Therefore, z equal to 2i minus 2i lie inside circle, inside mod z equal to 4. Okay, then what I have to do? Both lies inside. Both lies inside. So 1 by z minus 2i, 1 by z plus 2i. Whenever both lies inside, you better go for partial fractions. That's better. Z minus 2i, 1 by z plus 2i. What is extra term? If I take LCM, 2i plus 2i. 4i is the extra term. So divided by 4i. Now this is easy. So integral over c 1 by z square plus 4 dz is equal to 1 by 4i. I'm taking outside. Integral over ci z minus 2i dz. Integral over c 1 by z plus 2i dz. See, both the points lies inside. Both the points lies inside. Remember that point. Okay. Here, what is f of z? Here, what is f of z? Numerator function 1. Here, f of z is 1. So, using Cauchy integral formula, we have what is this value? This is equal to 1 by 4i. The first one is what? 2 pi I into f of 2i. Second one is what? 2 pi I into f of minus 2i. Anyway, what is f of z value? 1. F of z value 1. So 1 by 4i. This is 2 pi. Since it is a constant function, the value becomes 1. So this value is 0. This value is 0. Any doubts? Any doubts? Okay. If you still any doubts, it will be clear in this problem. See, evaluate. Integral over c e power z by z into 1 plus z whole cube dz, where c is mod z equal to 1 by 2. Okay. First, the function e power z by z into 1 plus z whole cube is not analytic. Not analytic. At what point? At z equal to 0, z equal to minus 1. Z equal to 0, z equal to minus 1. And here, what is the circle? C is what? Mod z equal to 1 by 2. Therefore, z equal to 0 lie. If I put 0, it is less than half. Z equal to 0. 0 is less than 1 by 2. Lies inside circle. Inside C. And what is another one? Z equal to minus 1. Z equal to minus 1 lies outside C. Outside C. Since mod z equal to what? Mod minus 1 equal to 1 greater than 1 by 2. 1 greater than 1 by 2. Okay. Radius, the one value is greater than the radius. So only one point lies inside. What is that? Z equal to 0 lies inside. Z equal to 0 lies inside. Therefore, so which function is treated as what? E to the power of z by z into 1 plus z whole cube. Now this can be rewritten as, okay, see, I will write directly dz. To apply Cauchy integral formula, which one is singularity? Z equal to 0. So keep z in denominator and take this 1 plus z whole cube to the numerator. Now this is my f of z. Here, f of z equal to what? E power z by 1 plus z whole cube. And what is a value? Z minus 0. Done? Z minus 0. A value 0. So using Cauchy integral formula, we have, what is this value? Integral over c e power z by z into 1 plus z whole cube dz is equal to, okay, 2 pi I into f of 0. That is 2 pi I into e power z by 1 plus z whole cube. This value at z equal to 0. Right? So this is what? 2 pi I. That's it. E power 0, 1 by 1 cube. Answer is 2 pi I. Is it clear? Still you want more problems? Yes? Next, evaluate. Now see this problem. Integral over C sine square z by z minus pi by 6 whole cube dz. Z minus pi by 6 whole cube dz, where C is the circle, mod z equal to 1. Mod z equal to 1. Solution. Solution. Here, sine square z. First, don't declare f of z. Always remember, z minus 6 whole cube is not analytic. At what point? At z equal to pi by 6. And what is the pi by 6 value? And z equal to pi by 6 lie inside, right? Inside mod z equal to 1. Then in brackets you can write mod z equal to mod pi by 6. Mod pi by 6 means it is less than 1. So lies inside. Lies inside. Then what we do? See, the problem is, still I will explain this. For example, if C is, this is what, 3.14 now. Okay, if what is the exact value? 3.14 by 6 means how much? How much? This is 0.5 something now. Okay, if mod z equal to 1 by 10, for example, if mod z equal to 1 by 10, C is mod z equal to 1 by 10, then sine square z by z minus pi by 6 whole cube is everywhere analytic. Everywhere analytic in mod z equal to 1 by 10, because z equal to pi by 6 lie outside C. Outside C. Okay, hence, so this entire function is analytic now. This entire function is analytic now. Hence, by Cauchy's theorem, integral over C sine square z by z minus pi by 6 whole cube. Dz value, what is this value? 0. Okay, I think you got now clear picture. When the function is entirely analytic, you consider f of z as the given function. Okay, if it is not analytic and the point lies inside, see, even though singularity is there, but the singularity lies outside. Hence, this entire function is analytic. Apply Cauchy's theorem, its value 0. But here the singularity lies inside the circle. Inside the circle. And one more important point. The function is not like sine square z by z minus pi by 6. If the function is z square, sine square z by z minus pi by 6, you can apply directly Cauchy integral formula. Because it's, what is the structure of Cauchy integral formula? Integral f of z by z minus a. That's it, dz. What is this value? 2 pi I into f of a. But this is not of that structure. Remember this function. In this function, whole cube is there. Whole cube is there. When such type of, that means in the denominator, whole cube, whole square, more than 1 degree is there. Now, here we have to use, Cauchy integral formula for derivatives. Cauchy integral formula for derivatives. This is the case. When we have to apply, when there is a power here in the denominator, something whole power, more than 1 power is there. And what is the formula? What is that formula? Do you remember? I told you f nth derivative at a equal to 1 by 2 pi I integral over c f of z by z minus a whole power n plus 1 is there. This is the formula, right? So what is this integral now? Integral over c f of
So
I.
in numerator, n factorial will be there.
Yeah, exactly. N factorial. Very good. This is z minus a whole power n plus 1. Our integral is...
Sir, it's n plus 1 factorial.
No. N factorial. Sure, n plus 1 or n?
N factorial.
No, sir, n factorial, sorry.
Wait. First derivative. Yeah, only one. Second derivative, 2 will 2 n factorial, right? Integral over c. See, our integral is this structure now. F of z by z minus a whole power n plus 1. Isn't it, right? Check this. F of this is my f of z by z minus a whole power n plus 1. That is the integral. So what is this value becomes? 2 pi I by n factorial nth derivative of a. This is 1. This is 1. Okay. Where z equal to a is the singularity. Z equal to a, the singularity lies inside C. Inside C. Now coming to our problem. Therefore, integral over C sine square z by z minus pi by 6 whole square, or in sine square dz we have, what is f of z now? F of z is what? The numerator, sine square z, exactly this. Compare these two. And what is the a value? Pi by 6. A value pi by 6. This is whole cube. This is whole cube. Okay. Therefore, using one integral over c sine square z by z minus pi by 6 whole cube dz is nothing but, since whole cube n plus 1 is 3. So what is the n value? This is 2 pi I by n value 2 factorial. And what is the n value? Double derivative of a. Double derivative of a. That is equal to 2 pi I by 2 f double derivative at a value pi by 6. Okay. Now I am calculating here. F of z is what? Sine square z. Double derivative I am calculating. F dash z, 2 sine z cos z, sine 2z. And f double derivative is what? 2 cos 2z. So this is what? Pi I 2 cos 2z at z equal to pi by 6. So this is 2 pi I into cos pi by 3. Cos 60. 1 by 2. So answer is what? Pi I. Answer is what? Pi I. Any doubts in this one? When we have to apply derivative formula, just by watching the problem, if there is in the denominator z minus a whole power something is there, then immediately you remember this formula. You remember this formula. From this, write the required integral. That's this value. Identify a value, f of z value, and n value. That's important. That's important. Okay. And n equal to 2. N equal to 2. Okay. Now, let me solve another one. Oh, already time is up. Okay, try this assignment. Just practice. Evaluate. Anyway, I'm giving solved problems in the textbook as assignment because you may be thorough with this. If any doubts, it will be clear for you. Where c is mod z equal to 3. Second one, integral over c e power z by z square plus pi square. Solve the second one compulsory. Where c is mod z equal to 4. Mod z equal to 4. Right. Next one. Third one, integral over c cos 2z z square minus 4z plus 5 dz, where c is mod z minus 1 minus 2i equal to 2. Equal to 2. That is over. fourth one. Yeah, fourth one. Integral over C e power z plus sine pi z. E power z plus sine pi z by z minus 1, z minus 3 whole square, z plus 4 dz, where C is mod z equal to 2. See, in this one, in the last problem, what the singularity is? 1, 3, minus 4. And which lies inside? Only 1. 1 is less than 2. Here 3 is there. 3 greater than 2. Here minus 4. Mod minus 4 means 4 greater than 2. So only this z equal to 1 is singularity. So take these two functions, z minus 3, z plus 4 to the numerator. Apply Cauchy's integral formula. Cauchy's integral formula. And the last one. Integral over C 1 by z into z square minus 1 dz, where C is mod z equal to 2. All the 3 points lies inside. Z equal to 0, z equal to plus 1, z equal to minus 1. Take the partial fractions of this and in this evaluate separately. Evaluate separately. Any doubts?